Welcome back to CodinGame Coding Escape. Um, we are on to... Hello, Mara. The last one I did, these two, Castel Sant'Angelo. The first one was really bad, actually. There was a really stupid puzzle where the picture in the game didn't even match the format of the puzzle, and it was just really poorly done. Second one was pretty good. So apparently these two actually follow on the story. So the story's a bit weird. Is that there's like a pandemic, and by the way, this puzzle was released at the end of 2020. Um, there's a pandemic, and you got to find a cure for it. So you go back in time to Rome during some era, and looking around in the offices in the museum and trying to find a cure. Anyway, we're onto this one. Oh no, we were okay. We were in the present. We were looking in the museum office, trying to find a source of a cure back in history, and now we're traveling back in time to go get that cure. I think that's what's happening. Aguateca, year 770 AD. A handful of men and women managed to infiltrate the powerful Mayan Empire at the highest level. This group was part of the Aguateca sect, which had by then expanded its influence in the pre-Columbian world. Their aim was to extend their power in order to destroy the impure. Under the guise of building a temple dedicated to the glory of the supreme god Viracocha, they had succeeded in constructing a real underground fortress where they could meet to carry out their project. Their power was based on an immense treasure that was hidden in this temple. You have been sent back in time to research the source of a pandemic that may wipe out humanity. By analyzing the enormous archives of the station's database, a strange correlation between the structure of the virus and the sect's emblem has led to an interest in this temple. First of all, you will have to find the location of this temple in a Mayan complex. We're counting on you. Good luck. All right. I think there was more story than was needed right there. There's a pandemic and we're looking for the cure. That's all we need to know. This is 1 hour 30. It's gonna take a bit longer, probably. Code easy, logical hard. Like that usually means it's harder, because if it's code hard, that's not really a big deal for me. It's the logic being hard is gonna be the harder thing to crack. I don't even know what search is. What's search? Just finding things on the screen? Because they have icons, so I don't know what they mean by search. Alright, let me just grab my coffee. It's fine, you have me, the genius. Well, where were you when we needed you yesterday? 2 days ago. Yeah, that puzzle back then made no sense. Oh, we got some Aguateca ambient sounds. Alright, let's have a look at this. Turn the music down a bit then. Alright. We've got Temples are placed on a grid. Here's a visualization. The main temple on which we are located is at the bottom right. The coders have access to the list of these temples with their coordinates. Okay. List of coordinates of temples. Okay. Okay. There is a mechanism with different stone blocks, 8 by 8, that can be pulled or pushed. Each block can be pushed in between position 0 and position 6. Okay. So it can be 0 to 6 for each block, basically. So we need to provide a pushing array to open the door. Not sure what this is about. And down here, what we got? A reflector is locked in the center of this mechanism. Okay. So, it's a brute force solution for this one. Well, there's, what, 2 to the power of 16? Which is, what, a million or something? 64,000. No, it's 65,536, isn't it? Okay. Not sure what we're supposed to do with these. Lever you can raise and lower as many times as you like. So you can give a sequence of ups and downs. Up to 10,000 of them. Okay. And then over here, there are 10 holes above this door. It is possible to place the blocks of the first row in any hole of the second row. Several attempts possible. Well, it's always several attempts possible. What do they mean? Or do we provide multiple solutions? Are they actually inviting us to brute force this one? Let me test this out. So if I do... I think they are inviting us to brute force this one. So, okay then. Could do that. For... Oh, which Which of the many IT tools modules are we using? Tools, import. I don't know if that's what they were expecting us to do, but it's 1,024 possibilities. I think fine, we'll just do it. I think it probably is actually what they're asking us to do. I always forget which one we want here. It's gonna be one of these four, isn't it? So it'll be product 01. Repeat equals 10. Right? That's that. Or are in product Cartesian product. Let's just do it to 4, for example. Why can't I run it? Have I disconnected from this? Okay. Yeah, and then we want... Okay. So we want try solution... join it up. Change that to 10. There we go. Brute forced it. We opened the door, but did this change? But we can't go through it. What things have we got? We've got a bunch of... Okay, so this is 8 by 8. Ah, okay, so this is what we probably want for... What was it? This. But... each of these is like 1 to 6, or 0 to 6. 1 to 6 if it was like, say, a temple or something, but... we don't have any notion of depth here. What is this? That's 1, 2, 3, 4, 5, 6, 7. It's not 8 by 8. And this one we want 16 zeros or ones. What? Okay, have we seen anything like that? Like, not those. Ah, okay, down here. You can't even see that one down there. Alright, so this one is like 1s and then a 0. I think that last one is just ones. Alright, let's start with that. Or just do manual. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. Oh look, that's already got a... Oh, because we put... So if I put 1... Oh, the picture doesn't change. There's one missing here. Or do we want it the other way around? So the reflector is currently like this. What does that mean? What's this down here? Try the second. Okay. That'll be 1, 0, 0. Yeah, 1, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 1, 1, 0, 1. Press the differences between the first and the second. Okay. You'd have thought we'd be able to extract this as an input though, but okay, so like the XOR, so 0, 1, 1, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0. Lost. How many was that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. One, 1. That seems a bit random. 0 to 6, so 7 values for each of these. The empty space on the first one isn't the same in the second. What? I don't know which empty space you're talking about. If it were a clock, 11 would be empty in the first one. Yeah, but in the second one it's... Yeah, but I started from the top. The top one was 0. And go clockwise. What are these things on top? Yeah, are these the reflector dishes? That doesn't really look like it either. Lever that you can raise and lower as many times as you like. Try... Does anything change when we do this? What is this supposed to be? So it's 5 across. Is that pattern of temples? So there's a diamond at each corner. So is it like... This seems really obscure, but what if it was like... If you're going across, you go down, then up, then down, then up, down, or the other way around. It's literally just alternating. Up, down, then up, then down, then up. Diamonds could mean up. It's a straight path. So down, down, up, up, down, up, down, down, up, down, up, up. And then we can try the other way around, I suppose. Did I? Up, 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 up. Okay, I got it. If I go Oh, that space there. Oh, damn. Yeah, I did miss that. Okay. Which way do we want to go? Do we want to go from the head or to the head? Or try both. Okay, start again. So, down, down, up, up, down, up, down, down, up, up, down, down, up, up, down, 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 up, 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 down. Okay, I suppose we can try the other. Can we? I'll just do it manually. Down, up, 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 up. Down, 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 down. Up, up, down, down. Down, down. Seems too random though. Have we seen a diamond anywhere? This is so obscure. So we are here. Oddities in the map. Yeah, there's a bit of a line there, but... Five two. Hmm. The data we get is just coordinates though. Why would they impose a limit up to 10,000? It's like, what does that mean? Like, oh, is it? I'm supposed to use a lot of moves? Can we not go inside? Pushed or pulled. Position 0 and position 6. Maybe we could just push the positions of the temples all the way in, but what is the point of the depth? Alright. So we're going from here. Or maybe... So starting from... Let's say we're trying to move the head. So you would go down 2, then up 1, and so on. Let's try that. Like, let's say we're trying to move the head to that position there. So you'd go down 2... And then I guess the diamonds mean it just goes to the next diamond or something. I don't know. Then you go up 1 and you go 1, 2, 3, 4, 5. And 1, 2, 3. And 1, 2, 3. And 1. I'll just take away that first one. I could use a hint. I've got hints. There's no real direction here. What are these pictures? Alright, let's use a hint. Which one do we want a hint for? We've already opened the door. The reflector. Snake. Yeah, let me look at the snake again. We might be on the right track with a snake, but there's just like several different things it could mean that all kind of make similar sense. Alright, let's take a hint for the snake. The lever represents a snake. This symbol can be found near the labyrinth on the wall. Right, well, we've already... Well, I didn't notice the symbol. Let me have a look. What symbol? That symbol there? I can't see anything really. Oh, okay. Yeah, fine. So the lever is connected to the snake. We already kind of assumed that. But... like, if we're trying to move the snake... or... there's another snake head there? There's one by the lever, yeah. Is the path different? What path? We don't really have a... does it have a body? Oh, you mean this? Yeah, different. So the hint is telling us that the snake matches that. Alright, let's take the next hint then. The lever must be operated by following the movements of the snake from tail to head to move through the maze. I didn't try tail to head. Try that then. But from which square exactly? From... you can't even see any tail. So, are we assuming tail is this space here? So we move into it, so it's like... and then you go down. Oh, okay, it wouldn't matter, because you go down, you go 1, 2, 3. 1, 2, 3. 2, 3, 4, 5. And then onto the head. Or not, that last one. Or is it just... you just do it once for each turn? We tried that before, didn't we? Down, then up, then down, then up, then down, then up. No, it's not that. The lever must be operated by following the movements of the snake from tail to head to move through the maze. I don't think these puzzles are designed very well. Like, you should have something, like some simplified version of this maze as an illustrative example of something. Like, there's so many different things I could do. None of them make any more sense than the other. Alright, whatever. Take the last hint. The wall shows a top-down perspective of a labyrinth. The leftmost brick is the entrance. Okay, whatever. It's just arbitrary. That apparently is the entrance. So you would start off facing the right-hand side of the wall. Activating the lever to go left-right changes the direction you would be facing in the labyrinth, but it's not... The lever doesn't go left-right. It goes up-down. What? And once you turn to the right, it's no longer like perpendicular to you, is it? So they're saying it's one lever for each corner. What? Oh, right, yeah, okay. Yeah, we do it once at each corner. That part makes sense because that's sort of what the diamonds mean. But the fact that up means turn left and down turns right, that's nonsense. Alright, if that's what they mean, let's try that. So it's... We turn right, so we... But this is just basically what I did, isn't it? Oh, no, it's not what I did. Okay, so yeah, we turn right, which is down, apparently, and then turn left. Then... Why didn't they have the lever going left or right, then? Oh, God. Right, then left, then left, then left, then left, then... Right. Then right. I don't know if I did that right. Start again. So we turn right, then left. Then we turn left. We turn right, then right. Then we turn left, then left. And now there's 4 to do. It's left, left, right, right. 5th is up. Start again. So the 5th is this one. We turn right. Down. Okay, so right. Left, left, right, right, left, 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 right, right. Even with all this information, it's still really arbitrary. What? The leftmost brick is the entrance, so you would start off facing the right-hand side of the wall. Activating the lever to go left. Maybe up is right. Makes even less sense, but... Fine, we'll try it. Up. This is gonna mess with my head now, so... Down, down. Up. Why would it be... up to go right? That feels even less natural than... Oh my god. Is there anything around that would indicate that that's what you do? Like... Ah, wait. That's what those arrows mean. Oh my god, that actually makes sense now. It's saying pushing the lever up equates to going right. Turning right, I guess. And pushing the lever down equates to turning left. Okay, fine. That tells us the directions. The bit which still is a bit weird is why you would even assume you're standing at the tail and entering a maze. Like, we don't have anything which sort of indicates that. Like, my first instinct would have been to move the head itself. Or start from the head and move to the tail. But, okay, I can... The directions were spelled out there. That's... I can accept that. Okay. What did that do anyway? Caused stones to drop from a wall. Okay. I think... So each of these corresponds to one of these patterns, right? So... First... Well, where do we even start? Alright, so this one here... 3 things... That is... the first one. And then the next one, is it like the 3 things with filled in? Yes. And there's 3 tiles between them, and then there's 4 to the next one. And then 2 to that one. Okay. So it's like 3 or 4. We've got some sort of notion of amounts here. Why? But these are just binary. And these are like snake tiles. That one's a different orientation, but that doesn't matter. Why is it different orientation? So that might matter. So are they saying the snake has something to do with it? I don't see how we can incorporate these amounts into anything. So we are here, essentially, in terms of, like, this thing is set to that one, and there's nothing there. Like, are these, like, if you combine this one with this one, you get that, right? I mean, each snake is how many times you input that wheel. I don't know if it's supposed to work like that. I think you're supposed to get like a success or a failure. And you can only input one answer. Unless it explicitly says you can enter multiple solutions or do try solution multiple times. And I hope that's not what you have to do. So I mean, what we did before was one means press. I feel like looking up another hint. These are just too random. What are we trying to do here? Like, put this on that or something? Take another hint. And we've still got this one. Opening the door. We've opened the door, haven't we? Or is it not fully open yet? Alright, let's look at the reflector. It looks like the reflector could be done before we even saw this anyway. Let's have a look at the reflector. The circle of white traces on the wall is the same as the one below the left reflector on the roof. Yeah. I mean, do we just want to make it... Okay, whatever. Next. The circles of white traces below the reflectors fit into each other. What do you mean fit into each other? The circles of white traces below the reflectors fit into each other. No, they don't. What? They don't fit. You have to press the yellow buttons which have a white trace on all the circles below the reflectors. But they don't fit into each other. So that's nonsense. So they want us to take like the intersection between the 4. Wait. On all the circles below the reflectors. So what, these 2? Why? Or these 2, because we're trying to put these 2 together? Or all 4? Ooh. All of them. Is that called a reflector, that thing there? I guess that's implied by the first hint. Okay, fine. So we want to take the intersection between all 4. They don't even provide this as an input. Okay, so 1, 0, 0, 1. I could barely even see the last one. Wait, is that what they mean? Yeah, the intersection. Alright, so 1, 0, 0, 1, and then there's 0, 0, 0. It's really just the 2 middle ones you have to focus on. But 1, 0, 0, 0, 1, 1, 0. How many is that? Then we need last couple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 2 more. So it'd be 0, 1. No, not the last one. Wait. Hang on. That means it would be 0, 0. I would have thought you would actually sum the middle 2 to get... I don't know. I didn't have any real thoughts, but that one's just random. What? The intersection of all 4. And for that, they should have given us the input. Like, that's what this thing is for. That's why we have inputs and outputs. Okay, so we've got a reflector. Now the height puzzle. So what did that... Did that tell us something about the heights of things? So is this... Yeah, but I'm thinking that the reflectors, like, you would use them to maybe measure height. Probably for later when you have all the reflectors. Oh, okay. I haven't seen another reflector. That's done. Okay. Then maybe the height puzzle is supposed to be just solved on its own. Yeah, you can see them in the background. I was just thinking that, but you can't really count the heights or match them up. That's not... Each shape tells you the height. Do we have a reference? Oh, we have some diagrams here. Oh yeah, we do, don't we? So this one is height, what, 3? But, oh my god. Okay, fine. So that's, we are in this corner. Alright. I just copy... Oh. Okay, if we just modify this, let's take this as input. Or just copy this. Is this the data? Yeah, it's not. Okay. And then just type in the heights for each of these as like a H value or something. Alright, so grid, or I don't know, positions equals the empty tiles are 5 or 6. Oh, okay, fine. Maybe number of crosses. Why are there 2 crosses up here? Okay. Maybe make sure that computes. Okay. So let's have a look at this then. So we're saying so 0, 2 is that one. It's what, that in the distance there? It's like the diagonal. There's this one as well. So diagonally opposite us, there's one on the left, one on the right. That is... can't tell. I think that one, I think, is this one. 0, 2. But I can't see the other one. It's behind. Alright, well that is... what kind of pyramid is that? It's just like a normal one. That one. So what, 4? Alright, 0, 5. So 0, 5 and 0, 7 are that one and that. Wait, what's... 05 and 07 are that one and that one. Yeah. So, though that one is... Okay, 02, 05, 07 are that one, and that one. But what's that one? That's even further. Ooh. What's this one? Okay. That one and this one are those two. Okay, fine. Alright, I can see these three and these two. That fits. I don't understand what that one is. Don't worry about that for now. So this is like a... that shape, and then we've got like a standard pyramid, and then the two towers one. What is that shape? Alright, let's look at the thing. That. So we've got two towers with a pointy one, and then there's two balanced towers. That's neither. What is that? I can't tell what it is. Is it like this one? But it's got a bunch of chimneys on top of it. It looks similar to this one, but... Okay, I don't know what that is. That one is a pyramid, and that one's two chimneys. Okay, so... that's 4. This one. And then this one. 2. And that one is, I don't know, put question mark for now. So the next row, okay, so that one, I don't know which one that is. Is it that? But that's further away. Alright, we'll assume it's that. That's just a pyramid. So it's going to be 4. Alright, and then if we go to these two, 2, 4 and 2, 6, that is this one here and this one. So it's another pyramid. And then we've got 2 balanced things. I think this one might be the 2 balanced ones. I think this is actually 4, but you can't see the other 2, they're behind. So that'll be 1, 2, 3, 4, 5. Alright, 4, 0, 4, 3, 4, 7. These three. So that, and that. Yep, that's right spacing. So it's one of those ones. So 2. And then the next one is a standard pyramid. And 4, 7 is this one here. Which is 2. Alright, then 5, 2, 5, 6. 2 in a row, so... that one in the distance? That's quite far away. Hang on. Oh, that one... that one right in the distance must be 4, 0. What does it line up with? Doesn't make any sense. What is this one here? Because there's nothing here. So it could be... Four, 3? I guess so. So 4, 0, 4, 3, 4, 7 is... What? That one? Then this one? 4, 7 should be right... That one there. Oh, I don't know. Yeah, and what's that one hidden behind there? Oh, this is ridiculous. Yeah, that's 2, 4, 2, 6. Alright, we'll assume the 4 row is... They're kind of evenly spaced, so it's definitely that one. And then... I guess that one? Can't be that one, because there's one even further, and... 4, 0 is like the end of the line. Oh, why did they do this? Alright. That, and that are clearly the 0 column. I don't know what this big one here is. Probably... Probably 4, 3, even though it seems quite far away. Okay, we'll accept it as 4, 3. So the 3 on row 4 are that, and that. It's a bit weird, but okay, we'll do that. And we assume that pyramid is actually 2-4, even though there's no gap between. For goodness sake. Should we just read the hints? Are they going to give us a better way of doing this? With the help of the perspective, or maybe if you got your perspective consistent. Okay, should we just take the heights, because I can't decipher this. This is not even drawn properly to scale. Like what is this pyramid? That and that, like, are they on the same row? Okay, clearly they're either on the same row or not far apart in terms of row. But if you look at this, they would have to be that and that, probably. But there's a whole row in between them. But there is not a row between them like that. Alright, we'll just take the solution. I think I'm done with this puzzle. Let's see how that matches up. So they said 4... Alright, whatever. I'm not interested anymore. It's not going to be the right format, is it? We need a... Nope. That was... Wait, so they said... Okay, it doesn't matter. Now what? I can aim them at 4 different temples. You must return the list of the 4 temples to aim at in the form of XY coordinates from the left reflector to the right one. Oh, interesting. Okay, I think I might know what to do here. So... I think we want to find 4 temples which fit this pattern. So there's like 1, 2, 3, 4, distance 4 between 2 in a row. Then you go up 1, 2, 3, 4, 5, and then 1, 2, 3. So 4, 5, 3. So it would be like... Okay, that's it. It's 5, 6. Can't do it manually. Okay. Oops. So it'd be 5, 6. Then hang on, no, the other way around. Y is 5. This is 6. Then 5, 2. Then 0, 2. You normally take Y first because that's the row, and then 0, 5. Okay, that was a terrible one. trying to decide whether it was worse than that other one. No, this one was worse. Well, to be fair about the lever, it did actually say what left or right means, but there was no, like, indication that you were in a maze and you're facing a direction or anything. There's just so many ways of interpreting that. Give that one a 1. Shall I move on to the next one? Yeah, go on. We can probably start being a bit more liberal with the hints now because they're getting a bit silly. The writing of these. That's probably why this coding escape thing never took off. It was such a brilliant idea. And it was good for the ones that were done for the competition. So it was that one. But then I guess these ones were just badly written. So this one is code hard, logical, easy. Good, that's what I want. I just want to know what to do. Because they think they're being hard with the logic, but they're just being obscure. There's a difference when you're writing puzzles. There should be a logical path to deduce that this is what we do and nothing else. Otherwise, it's just not a good puzzle. It's not fun. Same story. Alright. Hopefully this one will be better. It's more focused on the coding. I was just reading something. Okay, so alright, let's do this. I'd be surprised if it's worse. Yeah, no, if the emphasis is on coding, not rather than logic, then I would hope it's better, because I don't think they're good at writing puzzles. Logic puzzles. Whoever wrote this this whole series. Okay, I'll be right back. The Sherlock ones were fine. Yeah, the Sherlock ones were good. And the ones that they launched with in the competitions was the Steam Room one, which I think was good as well, and the Haunted Mansion. I think so. They started with those. They probably got good writers for those, and then they were trying to make a product that companies could like buy and like pay a subscription to and like use to like let their software engineers practice or something, and they just didn't make very good ones. It's such a good idea for a genre. Like I've not seen anyone else do this. So if they had, I mean, clearly they're able to make good interactive games because they do the coding game thing, which they've done every like twice a year for the last decade. I guess this wasn't selling. Sometimes you have these things which are actually a really cool idea, but no one's actually buying them. All right, let's go. All right, we're in the temple now. So we've got one of these things. You can set the angles. Okay. Might be solvable as is. Let's just have a look around first. The water is held back by 3 pieces of wood. They can be moved by moving the right-hand square so that the rod passes through the notches provided. Oh no, it's a sliding puzzle. Oh, I gotta code a sliding puzzle? I have done that before. That was like the first thing we were taught to do when I took an AI course in university. We did it using like A star algorithm. I mean, you're better off doing it by hand if they'll let you, will they? Oh, you can. No, but you gotta know ahead of time what you're gonna do. So we would have to build our own sliding puzzle. Or just take... I mean, okay, we can code it. In less than 15 moves. Fewer than 15 moves. Okay, so it actually has to be like shortest path. Actually not that hard to code. But we could totally solve this by hand. Let's try it. I used to know like the algorithm for solving any sliding puzzle ever, because it's actually not that hard to do. And I remember I learned it because I wanted to speedrun a game. I think it was called Lenny Loose Jocks, an old Shockwave game. Or an old web Shockwave game, and in that they had a sliding puzzle. I think it might have been randomized, so the only way to be good at speedrunning it was to be good at sliding puzzles. So I learned the algorithm. I think you start with the corner... No, you start with the top, the 4 in a corner, and then you kind of go layer by layer outwards. And this was like a 9x9 grid, I think. This is only 3x3, so this should be quite easy. Wait, is this the starting position? Okay. Wait, so 8, 5, and 3 are already in the right place. Does that mean we don't need to touch the right-hand column? Because sometimes you need a bit of space to be able to... So if we were just to rotate this whole thing clockwise... Then 6 would end up here, which is where you want it to be. Let's try... We just have to imagine this, but let's try... start writing an algorithm. In the algorithm... Either you use the algorithm which is established for this, which you don't need to come up with yourself because it's already being written. Which, I can't remember how it works, but like you start with like... Similar to a Rubik's Cube, you start with the corner section, you move it layer by layer. Or you just write A star. But A star will be slow for really big sliding puzzles. And the state would be like just the board, and each left, right, up move, left, right, up, down move would go to another state. So that's your neighbors. And your heuristic would be number of positions in the correct spots. Alright, so let's go... I'm just gonna scribble here. Let's say we went... right... up... left... No. I had something in mind here. No. Right, up, up. So you move these 3 into these 3 positions. Then you go... No, take away that up. Go left. Right, up, left. So these 2 move up here. This fat one moves to the left. Okay, so now these 2 are kind of in the right position for the bottom row. So move this one up. We go right down. So now the bottom row is complete. And what have we got left? This fat one is there. That thin one is there. And this one is here, so... So... We're done. We just go left, move this one to here, and then... Hello, DJ. Trying to solve this by hand instead of coding it. Down, right, up. I think that might be it. And then there's a gap here. Try that. Let's just write it out by hand. Don't know if that was... Okay, that was it. Like, I could have opened up, like, Photoshop, created a layer for each of these, and then dragged them about. That would actually work. Or just, like... Yeah, just copy that image into Photoshop, cut out each of these. Wouldn't be too hard. Sliding tile puzzle where you can slide the tiles. Can't slide the tiles. Conceptually you're sliding the tiles, but yeah, you can't actually You're supposed to use code for it, really. But code, unless you're doing the correct algorithm for sliding puzzles, which I don't know off the top of my head, you would just have to use just a standard search algorithm like A star. And like I've done every advent of code, it takes me like at least half an hour to write an A star algorithm. Alright, so that's done. So that is a thing we can probably do as well. What? What is this? Okay. You can retrieve a diagram of the canals as a graph in the form of a list of links between each node. Ooh, a graph. Would it be a hex tree? Not really. There's a system for filling different containers. Oh my god, it's an actual... Is it a flow problem? Are we actually going to use that algorithm we never get to use? The Ford-Fulkerson algorithm for optimal flow? Alright, so there is a system for filling different containers. There are 12 openings with a flow rate of 4 that can plug or leave open. Oh, I see. So each of these is open or closed, so it's basically 2 to the 11. You could actually brute force this. Containers are marked A, B, C, and D. Flow rates to be obtained with one of the valid combinations are... Okay, so you just brute force and find one which results in that. There's a cybersecurity training website that stole your name. Okay. I mean, it's if you just take a bunch of programmy-like words and put them together, I think it's not too hard to come up with hex tree, I suppose. That's fine. If people are searching for their website to do some cybersecurity, they'll end up on my channel watching me play Morrowind. At each intersection, the flow rate is divided into 2 equal parts or simply added up. Okay. So I mean, you can reason some of this out, but... like, for example, 0 would probably have to... Hang on, what was it again? 8, 8, 10, 6. It's like these 2 would have to add up to 8. If 0 was 0, then that would be 0, so that would have to be 8. Which is doable, I suppose. I think we just brute force this. I don't think we can really draw any hard conclusions here, other than I think it's unlikely that the top one will be 0. Okay. So we need 12 booleans. Alright, so we just want to iterate through these. So we say I mean, we already know that all the water you put in must be the water that comes out. So if the sum on the left doesn't equal 4 plus 8 plus 8 plus 10 plus 6, then already that's an invalid solution. That's an optimization, but I don't think we even need to put that in. It's probably fast enough. So I mean, we can just put that optimization in, why not? So we'll say if some R... Wait, so what does R look like? It's going to be a bunch of trues and... Yeah. What does print sum of R look like? It's going to be the number of trues, right? Yeah, okay. So if sum of R... So they said it's 4. Yeah, okay. Wait, plug? Wait, plug is a true value? Wait, what? No, open is true. Okay. So if sum of R is not equal to... So if 4 times sum of R is not equal to... let's just write it out explicitly. 8 plus 8 plus 10 plus 6. Continue. So how many does that leave us with? Not many. Oh, no, okay, there are a fair few. Fine. Alright. Alright, now let's try and solve. So... So it's just a series of sums. So why does... Whoa. Okay, they've labeled them. Why have they labeled them starting from... Okay, it doesn't matter. Oh, because these are 0 to 11. Okay, fine. So let's do them in the order that they've labeled them, because that's probably a good order. Let's say node 12 equals... Hang on, so... let's say node 0, node 1, node 2, node 3, node 4, node 5, node 6, node 7, node 8, node 9, node 10, node 11 equals, it's going to be 4 times x for x in R. Not enough values to unpack. Expected 12, got 11. Oh, that should be 12. Okay, so far so good. So that's the rate of those. So we just go in order. So we've got N12 equals N3. N13 equals... Oh, no, this is wrong. Hang on. We have to... We can't do them in order. We have to do... Okay. N13 equals N4. Then N12 equals N3 plus N13 over 2. So that splits. Well, let's go left to right. Oh, this is going to get confusing otherwise. So we do N13 and N15 equals N6. N18 equals N9. Okay, now go to the next layer. So it'll be N12 equals N3 plus N13 over 2. N14 equals N5 plus N13 over 2 plus N15 over 2. N16 equals N7 plus N15 over 2. N17 equals N8 plus N18 over 2. N19 equals N10 plus N18 over 2. And N20 equals N2 plus N12 N22 equals N16. Then N21 equals N20 plus N22 over 2. N23 equals N17 plus N22 over 2. Let's just check this compiles. I don't... Okay. Alright. N24 equals 0. And 26 equals N1. n25 equals n24 over 2 plus n26 over 2. Do they give us... No, they don't give us this as an input. Like, if you had a graph, you could probably actually... It wouldn't be too hard to write this, but you would need to topological sort to begin with to make sure you're going leftmost to rightmost. N29 equals N11, N28 equals N19 plus N29 over 2. N27 equals N21 plus wait, N21 is missing something. N21 should be N14 plus... Yeah, that one has 3 inputs. N14 has 3 inputs. And N7... yeah, just those 2. Okay. N27 is N21 plus N26 over 2. (35) equals N28. Alright. 31 equals N27. N33 equals N23. N36 equals N29 over 2 plus N35 over 2. Okay, and 30 equals N25 plus 31 over 2. And 32 equals N31 over 2 plus N33 over 2. And 34 equals N33 over 2 plus N35 over 2. Almost there. N38 equals N30. N41 equals N34 plus N36. N39 equals N38 over 2 plus N32. And 42 equals N41. 40 equals N39. N37 equals N24 over 2 plus N38 over 2. Four equals N42 over 2. N43 equals N40 over 2 plus N44 over 2. 45 equals N42 over 2 plus N44 over 2. A equals N37. B equals N40 over 2. C equals N43. D equals N5. If A, B, C, D equals, what was it? 8, 8, 10, 6. All it takes is one error here for this to all be wrong. Turn R. But it's not, is it as a list? We might need to cast it. Oh. Nice. See, that one I can actually see as being a good team puzzle, because you can actually split the work. Like, someone who's not a coder can rearrange that into a format that the coder wants, right? Like, they probably did that intentionally because they didn't give you the graph as a input, because they wanted this to be a team activity. So like, the non-coder converts that into a form that the coder wants. Like, the coder might want it like as a directed graph, A to B, so on. And meanwhile, the coder is writing up a general graph solution, given any graph, which is like probably uses fewer lines of code than what I've written for the general case. Yeah, because it's not hard. You're just computing a sum at each node. You need topological sort first to get the right order, assuming there's no cycles. And then you just go from, in order of topological sort, just sum all the inputs of each node. That is a good problem. It's a bit harder solo because I had to do all that myself, but it's just this left to do. I mean, the same sort of goes for this. You can split the work. One person would convert the sliding puzzle into a... Same goes for this, kind of. I guess that's kind of what they were getting at with these. We want to solve this. What do we want it to end up looking like? Okay. So... if we move that here... that would go like here. Wait, so the outer ring... oh no, the outer ring can be moved as well. So, but there's no point moving the outer ring, is there? Is there anything that's fixed? The middle is fixed. Okay. Okay, so that means there's only 2 possibilities for the ring. Either it's at 0 or 180. Let's write down. Yeah, let's connect these. Well, you do them one at a time. So 0 is where it is right now, right? Okay, and if I did 180... oh, okay. We could just do this manually then. So, start with 0. There's only 2 possibilities for that one, so let's start with... oh, it's from where it is right now. That makes the coding a bit fiddly then. Right. Better to do this manually. So we'll keep that there. The next rung Has to be... That's no good. We could just move it by 45 each time. Until it fits. That fits, I guess. Can't really... Wait. There must be... What are we even trying to do? So there isn't any alignment that actually matches the outer one with the next one. But we're not actually trying to fully align it, are we? What are we trying to do? Get from... Here... The water is coming in from up there, right? So we should turn this until... like that. Okay. Now go to these ones. Maybe like that? I don't know. Oh, wait. No, that's no good. Okay. Now turn that one. We can't move the middle one. Could try moving this one out. I don't understand. Is the water... Hang on, let's look at this again. Go out. No. Is the water coming in from above? It must be. The outlet is at the bottom. Yeah, I think so. So I assume the water's supposed to come in from the top. Or like that. Doesn't. I mean, that's okay. I think things like this don't matter as long as there's a path for this one, so... The middle one can't actually move. So maybe I should be starting from the middle, working my way out. No, but the outer one can only be in... That's why it's a funnel. What is... The one at the bottom? Can't even really do this with code, can you? Because you'd have to... You'd have to use the current state, and you can't take the current state as an input. Right, how many possibilities are there for this row here? There's only like... Is that... Oh, okay, I got it. Alright. Alright. Here is a beautiful statue. There's an engraved hexagonal pattern. Alright, we can extract... Zeros and ones, 1 per line, 0 for a raised square, 1 for a pressed square. Why would you do it like that? Just do it fixed width lists. It's just confusing. Alright. It's a 13 arrays containing 0, 1. Alright, fine. That's that pattern there. Is that... Oh, okay. I see. The width is following... Well, it's... Does that mean this is not aligned on the left? This should actually be... What does it mean? So there's... Oh, okay. So this should actually be pushed physically to the right. So that's in the center and so on. So it actually starts from the... Shouldn't the next row be... Yeah, it should be one more than the previous row. Okay, that's why it's not fixed width. Okay, that makes sense. So you'd have to pad it with zeros. So we can extract a hexagonal pattern from that. Yeah, okay. Oh boy. But that's a lot more hexes. What is this? Seven large hexagons themselves made up of hexagons. Retrieve the list of the 7 large hexagons that make up its pattern for each one. Okay, so that's like 7 hexagons. Right, so, okay, fine. So there's no, we don't interact with... Oh, we input a hexagon to this. No, do we? Oh, we can change it. So this button... This one shows us what's there. This one lets us change it? Okay. Fine. And then down here... You have to press the boxes to activate a mechanism. I can't move the ones marked in red. They change position by themselves each time I try. Presses on these squares will be ignored. There is a balance system. It seems that the sum of the presses on each row, each column, and each diagonal must be the same for the mechanism to activate. You have to make a magic square. Why do we have... Okay, let's take a look. What? We've got hexagons of hexagons in there. Alright. I can't move the ones marked in red. Wait, which ones are marked in red? Reddish light? Is that reddish? Okay. Oh, this gives us the data anyway. So each red square changes position with each attempt. I can retrieve the current pressure for each of these squares. List of pressures for each marked square between 0 and 100 from top left to bottom right. So this is just the marked squares. Okay, I guess it's the lit ones. Okay. Number between 1 and 100. We definitely can't brute force this then. So sum of the presses on each row. Okay, fine. The hexagons I assume are irrelevant right now. So we just have a grid. We've got the marked ones have fixed numbers, and we've got to fill in the numbers everywhere else to make every row, column, sum, and diagonal sum to the same. But okay, but it's probably more than one solution then, because it doesn't seem... Okay, fine. I can solve that, I think, and I don't know what to do with this. That's just one pattern. Okay. And this one's like a whole bunch of things. Alright, but this probably uses this. Oh. Okay. I guess we start with this one. Let's print for row and grid. Print row. 18, 15, 5, 13, 21, 18, 26. And we want to make... Must be the same. It doesn't say the number, it just has to be the same. Okay. So we probably want to figure out the number. So the second row from the bottom, well, okay. So you kind of solve it a bit like a Sudoku, or this? I would think there's like multiple solutions. So if we take the second row from the bottom, there's like only two values that need to be filled in here, and they can range from 0 to 100, so they could be 0. And it's not like you need one unique number in each row. It's just the sum needs to be made fixed. Alright, how do we go about solving this? Find the fixed numbers. Those are the fixed numbers there. Those ones are fixed. Oh. No, they're not fixed. They change position by themselves each time I try. What? Oh, hang on. If they change positions, that makes it more confusing. You need all the directional sums to be the same number, yeah. Let's try submitting something. See if it changes numbers. They do actually change. Is it just randomizing the puzzle each time so we can't brute force it? Not that I could even really brute force it because it's 0 to 99 in each square. Okay, fine. So it looks like every time you try this, it randomizes. We just keep randomizing until we get... Well, no, that's not going to do anything. The red numbers are changing, but none of the others are. Yeah, it's just a... Yeah, but we would still need to... It is a different puzzle unless they're changing by the same amount. I don't think they are. So that's, hang on, that's 13 more than that. Oh, it's always 13 more. Ah, no, that one changed. The puzzle is actually changing. That one is fixed. 21. But those ones are changing. Yeah, okay, fine. Can we just put... Can we just put like any numbers in most of them and then the final... I don't know how you even solve what algorithm you use to even solve these. Like as it stands, like for example, that row is 53, that row is 50, that's 40. The magic square? No. Because you can have duplicates. So that actually makes it harder. Without duplicates, because there's fewer restrictions. You could have a bunch of zeros if you wanted to. There's more possibilities. If it was a magic square, it'd be easier because you'd know exactly which 15 or which 25 numbers are in the grid. It's just where they're placed, and then you can rule out where certain numbers must be. But here, it could be any number anywhere. I mean, we could pretend it's a magic square and maybe it will work out, but do they ever have duplicates? Maybe not. So yeah, maybe there is a solution where the number's unique. We still don't know ahead of time. Oh no, look, there's duplicates. And we still don't know what the 25 numbers are. We have to decide. We could... Okay, well, like if I were to just put some numbers in... Alright. So that second last row has 3 numbers already filled in, so it's only a case of putting 2 in. So there's like basically 100 times 100 possibilities for finishing that row. And for each of those 10,000 possibilities, that would tell us what the sum is, and therefore what the sum for every row, column, and diagonal must be, if we're trying that one solution. From that, can ever the rest be easily deduced? If we plugged in 2 numbers, and then we got an amount, then then it's the left column. Like, it'd be really useful if we had we then ended up with a line with 4 filled in, because then we could fill that one in as well. Is there any other row or column that has 3 filled in? No. Okay. So let's a 0 is a valid number as well. Okay, let's just go with that. So let's say we brute force the second last row. If anything already sums to larger than that, then it's game over. Like, it can't be solved. So, okay, so we get a number from that. And we've got to make every... If zeros are valid, it should be easily brute forceable. Why would that make it any different from if they weren't valid? It's just changes the range from 0 to 99 to from 1 to 99. Isn't it? Like what? There's nothing special about 0. It's just another number that gets added because it's bare minimum inputs. Zero doesn't affect the total. Yeah, but it's still a possible input. I don't see it restricting anything because like we can purposely put zeros as in a few places. But there might not necessarily be a solution with those things being 0. So going with that, if I were to brute force the bottom row, that means 10,000 possibilities. Then a lot of those possibilities will be ruled out. For example, if we put 0 and 0 there, that gives us quite a low sum. So 50, 87. I mean that's actually doable. Okay, fine. So whatever. There's 10,000 possibilities for that row. Then what? Then we know what this row sums to. So to make the first column sum to that amount, whatever we set this one to, we know what the other one has to be. So we could just try values for that. So that'd be 10,000 times like another 100 possible values for that. It's already getting too big. 100,000, a million. A million is still doable, but no more than that, I think. So we'd basically have a million different attempts at filling the first column and that row. Can everything be fully deduced from that state? If we think we've correctly filled in the first column, that row, does everything then come into place? No, it doesn't. No. Okay. Whatever the solution is, if there were no zeros on the board, you could just subtract 1 from every cell, right? And that would retain the same sum for every row, column, and diagonal. And you could just keep doing that until there are zeros on the board. So there must be a solution with zeros on the board. We know 0 is a number that exists on the board. Sure. Because if there wasn't, you could just keep subtracting 1 until there is. So that's one fact that we can use. 0 is on the board at least once, but we don't know where. We can't choose the place. It could be here, but it may not be. So that's one thing, I guess. Doesn't tell us much, but current iteration has no repeats aside from 0. Yeah. I mean, there can be repeats, and sometimes there are no repeats, sometimes there are repeats. I think it's irrelevant. It's just randomized, or maybe it's not that hard. Maybe we just have to fill in a bunch of values with whatever we want, and then the last 4 or 5 values we can choose to make it work. Maybe it can actually be solved that way. So like, if I just leave the first row alone. No. I'd be trying to make the first column, the bottom left to top right diagonal, match the 4th row without affecting the 4th row's total. Okay. So what, plug numbers into one of these? Could grab paint and slap on the current totals for the layout to see the variance. paint and stuff on the variance. Well, I mean, when we click execute, we get a new input, so we don't know what the next we don't know what the input will look like when our code runs. This is just what it was for that case, and we didn't solve it. But it seems to be randomized, because sometimes there's duplicates, sometimes... These two stay fixed. 18 and 21 stay fixed. The variance looks to be the same. Variance? Like the differences? But it can't stay the same if 18 and 21 are staying the same. Total difference between the totals. The row or column sums. Okay, let's just try. Okay, fine. Let's try printing out the actual sums, I guess. So these are the sum of rows. Yeah, okay, so they're only changing yeah, that seems to be the case. They have the same 8742. No, they do change. So this one is 61 difference. This one is 56. R1 and R2 always has a difference of 3. Yeah, that does seem to be the case, yeah. So the solution numerically will always be the same. But the fact that these differences don't match, aren't the same, means that we could end up filling stuff in these zeros. That means they don't match anymore. I'm not really sure what the conclusion is from this. 17. I'm not sure what they really just look at the hints. Because even with the hints, I think this is still going to be quite involved. But I think Expecting you to do some really complex coding here. Mural. Wait, mural is the one we're doing? Wait, why are they looking at mural? We're supposed to be doing mural first? Ooh, maybe you get values from... Oh. Maybe these actually give you values, these hexagons, and makes it easier to solve. So maybe we're supposed to be doing this last. So the point of this is to get some values out of the hexagons. Maybe. Let's have a look at this again. So this gives us a pattern. And this gives us a bunch of patterns, but we can also give it a bunch of patterns. And like, if we wanted to extract number, could it be as simple as just the number of hexagons in that hexagon? But we can change it. Let's have a look at these hexagons then. Okay. Should we count the ones then in one of these hexagons? Let's say the top one. Wait, which order are these in? Would it just be that one first? And then that, then that, then that, then that, then that, that? Can we tell from this? 0, 0, 1. Looks like. Well, no, that's, yeah, that's the first hexagon. The ones are the dark ones, yeah. And then this is hexagon 2. And that does... Well, they all have the same first row. Okay, so that's 1, 1. So the second one. Second row, yeah. Okay, fine. So let's take the first hexagon. Or just for each hexagon, print sum of... Can you just sum lists to get a list? Let's just try this. Sum of... Hang on. Sum hex. What does that do? Otherwise I just have to write a big for loop. Oops, sum hex. It's a... Okay, whatever, fine. We'll just, show me what it looks like again. X. Okay. Print. So we want sum of, and then in here we want sum of R for R in hex, and then sum those outer values. Just get basically the number of ones altogether. 51, 56, 52, 51, 56, 61, 50. Okay. But do they change if I fiddle with this? Let's change this. They stay fixed. Okay. Okay. If we just assume that's the number, let's try that then. But why is the hint just talking about the mural? I think that I think there's something we're supposed to do with just the mural itself, not worry about the floor thing. So we can change this. Why would we want to? The only pattern we really have is it looks like Morse code up there. Is that, and we know we have, okay, we have that, the code for that pattern. Like, is it just as simple as we want to make that pattern in all the hexagons? Should we try that? I mean, you can change it to whatever you want, so let's try that then. So let's take that. And then put that. So we want so see, let me just have a look at this again. So we're given a hexagon. So just to return hexagon for just 7 times. Don't forget to return your results. Rang. Okay, so does that change it now? It doesn't change it visually, that would be probably too hard to program, but I'll print. No, that doesn't change. Why are we inputting something here? And putting the current hex totals in the magic square based on the orientation makes the most sense. Yeah. Alright, so we got the totals. I removed that code. Hang on. So 51, 56, 52. Okay, so we could change. There'll be 0, 4 to be the top right. Equals the top hex will be the first number, which is 51. Oh, you should be connecting this up. Well, whatever, we'll do it like this. Grid 1, 0 equals 56. Grid 2, 1 equals. They're doing them in. Oh no, they're not in order. Alright, so then the middle one. No. 1. Okay, so I think it would be fourth one this time, 51. And then we go to. This will be the third one. 2. Grid 3. 0 equals. This is 6th. Second from last, 61. Three, 2. This is the last one, which is 50. And then grid 4, 4. The third from the bottom, 56. So, is this what it looks like now? That's what it looks like. And the bottom row is, the second one bottom row is filled. So, once we've done that, we can say the row sum is going to be sum of grid 0, 1, 2, 3, 3. That will get us the row sum, which is 179 in this case. And then we can go and say we know what the bottom left one must be. So we'll say grid 4, 0 equals row sum minus, and then it's going to be, just write it out explicitly, grid 0, 0 plus grid 1, 0 plus grid 2, 0 plus grid 3, 0. That fills in that, and then that one is grid for 3 equals row sum minus, let's say, sum of grid last row. Okay. And then the diagonal. So grid 2, 2 equals row sum minus, and then this time it's gonna be like this, but it will be 4, 0, 3, 1, 2, 2, then 1, 3, then 0, 4. Okay. And then grid 2, 4 equals row sum minus sum of row grid 2. Oof. Inconsistent. Check, that's 60, 70, 103. So that's 179. It's also 179. So it's impossible with these numbers. I don't think we're going in the right direction then. Should we just read the hints? You must perform a transformation of each of the 7 hexagons of the mural according to the statue. Oh no. Okay, first of all, what indicated that? I don't understand. That's already rotationally symmetric, isn't it? What's not fully rotationally symmetric. It's for every. What? I don't understand. What? Why can't I click hints while I'm here? Each of the 7 hexagons of the mural. Wait, what exactly is the mural? This is the mural? What? They say we should rotate these hexagons. Based on what? All the tiles in the mural that are in different positions than the statue pattern must be pressed in and the others released. All the tiles in the mural that are in different positions than the statue pattern must be pressed in and the others released. Oh, okay. Transformation doesn't mean rotation. Thank goodness. It just means an arbitrary transformation. All the tiles in the mural that are in different... What? So we're not actually trying to make this pattern. Wait, what? No, we are trying to make this pattern. But... what do you mean in different positions? I don't understand. Make it match. Is that not what we did though? Just taking that and just pasting it 7 times? Like what? Positions being pressed, depressed. A 1 means change the position, not press. 1 means pressed. Does it? 1 and 0 references a position of the tile. But what exactly are we inputting? What the new position of the tile should be in, or whether we want to toggle it? Dark is pressed. Yeah. But then that should be already what we did, surely. One per press square. So what the current mural looks like shouldn't matter? I mean, it shouldn't matter, but I don't... I thought that the input we're giving is basically describing the dark light state of what we want it to look like, and what it currently looks like shouldn't actually affect that. But they're implying that you need to know what it looks like in order to... which would imply that a 1 would be a toggle, not a dark. But it very clearly says 1 is a pressed square. Oh, I'm about to give up on this. It's just... I don't know what they want me to do then. So what I already did was just paste that hexagon 7 times, which didn't feel like it was the solution, but according to my understanding of dark meaning pressed, it should just paste that pattern 7 times, which is what the hint seems to be implying we want it to look like. All right, let's assume 1 is a toggle. Even though it doesn't say that. Alright, start a new one. Say we look at this as all that are different are pressed. That's what the hint says. Wait, what? No. All that are different are pressed. Yeah, but what does the word pressed mean in this scenario? Like, does pressed mean toggle? Pressed, not alternate. But if something is pressed, it's dark, but it's light in the, like, let's say the blueprint pattern, then we press it, that does nothing, right? Is that... Oh. Pressing a pressed would just leave it pressed, right? Not pull it out again. But then it wouldn't even look like the blueprint. Round 1, same, do nothing. Fine. Let's try this then. That's the hexagon, that's the blueprint. And then we take this as the other input. And we've got a new output here. Let me say four mural hex in hexagons. So we're looking at a hexagon called mural hex. We've already got a blueprint called hexagon, and then we want to say for, let's say for J in for row I row in enumerate mural hex, so it should be the same dimensions for J in range length row. Now we're going I's and J's, we're going each one by one. If they're different, so if row J, so that's the J item, is not equal to hexagon IJ, then we change this to be a 1. Okay. And that's it. And then we would just return hexagons. This changes things in place. You should only, or it even tells you in the console, you should only press the tiles that are in a different position from the statue. You press the tiles that are in a different position from the statue. let's just rename this mural hex IJ. Should I just change this to a 0 then if it's not? So I had to put the 0 there. I don't understand what the reasoning behind that was. Literally copy the pattern, but what we've got isn't really copying the... If we're taking press to mean toggle, then I agree that that's copying the pattern. What we would end up with is the pattern if we toggle. But if we press, if you press something that's pressed, it stays pressed, I would think. And if you press something that's unpressed, it becomes pressed. But when they say the word press, they seem to mean toggle. So if something is pressed and you press, it unpresses. Which, I mean, some buttons work that way, sure, but... And then we get this. It was a very clear contradiction to what it said in the description of the inputs and outputs, where it just said 1 is pressed, 0 is unpressed, not toggled, pressed, because that has a very clearly different meaning from toggled. All right, and then we end up with this. Oh man, I don't really feel like continuing. I've got like spent almost 2 hours on this. Now what? What the heck is this? Can't get this as an input, okay. Hopefully we don't need this anymore. Is this changed in any way? Okay, so we've got that. So they're pointing to these rows. What? This is all nonsense now. Let's take this out. Leave it in because we might find it become similar in a way. Let's just move that down. So take that out. Ah, no, we need that connected to the input, yeah. Okay. So what do we do now? So we've got the marked ones, which we've got values for. Then we've got the hexagons, which point to tiles in that drawing. Is that like 34 and that's 30 and that's 40 and that's like tens and units? But which way around is it? No, I would think the hexagons are the units. Wait. I don't. Let's assume the hexagons are the units. And the lines are the tens. So go back to this. Grid 04 was the top one. Yeah, that's the top one, and then the left one. So the top one is, let's say, 30. And then the left one, let's say, is 43. And then these two are the middle and then the top right. Okay. So that's 11. And the top right is 40. And then bottom right and bottom. This one's 20. And this one's 34. Wait. How many hexes are there in each of these rows? 1, 2, 3, 4, 5, 6, 7. But sometimes it's 1, 2, 3, 4, 6, 7, 8. Maybe it's total number of hexes. Let's do this for now and then we'll change it. And this one is the bottom left, which let's say it's 14. I think it might just be the total number of hexes, but that's easily changed. And then the row sum is that as before. In fact, this all falls into place still. So far so good. No negatives. Okay. What's the last one we did? Grid the middle. Final one on the middle row. Okay, and then we can do the columns. We can say or just do the diagonal. So say it's gonna be like this. Grid 1, 1 equals row sum minus, and then this is going to be 0, 0, 2, 2, 3, 3, 4, 4. Okay. And then we can do the column. So grid 0, 1 equals row sum minus, and then it's going to be column is always going to be 1. And we'll go from 1, 2, 3, 4 like that. And then we can do that for the next two. So this one will be 0, 3. These will be 3, 3, 3, 3. And then yeah. And then this one will be 1, 4. Let me go. These will be 4s. Let me go 0, skip 1, 2, 3, 4. Uh-oh. Take this one out. Alright. I think it might just be number of hexes. Wait, was that last one correct? 0. Good. 1, 3, 2, 3, 3, 3, 4, 3. Okay. What are the number of hexes? So it's gonna be the top. So it's 1, 2, 3, 4, 5, 6, 7, 8. So 24. Then this one was 2, 3, 4, 5, 6, 7, 8, 9. So 4 times 9 is 36. Plus another 9, 45. And then this one was the middle. That's 10. And then this one was that one. 1, 2, 3, 4, 5, 6, 7. So 28. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 18. This was the bottom. What's going on here? 1, 2, 3, 4, 5, 6, 7, 8. And it looks like we can multiply that by 3 to get 24 and then add on 25, 26, 27, 28. A bit weird. Okay. 28 plus 12. So 40. Different lengths, yeah. I've accounted for that, I think. I took the 8 here, turned it into a square of 3 by 8, and then I added the 4 extra on. 1, 2, 3, 4, 5, 6, 7, 8, 9. Plus 12, so 21. Okay. Put that one in. Okay. And then grid 0, 2. We still have, I could just enter the numbers in, but we want it to be dependent on the input because they might switch it around when we return. Minus sum of grid 0, grid 1, 2 equals row sum minus sum grid 1. And then we return the grid. Pieces move, but nothing happens. Okay. I don't think we were supposed to move the wait, how were we supposed to give this? The list of pressures to be exerted on each square, but we're not supposed to move the showing the sum still. Or we're returning the grid. We're printing the sum, but we're returning the grid. pressing on these squares will be ignored, so it doesn't matter that we're trying to press. Or maybe these hexagons, that's already how much they're pressed, so we shouldn't press them any further. So it should be zeros now for the hexagons. So then we take this, put them back to 0. Because everything else was... I don't know. Sums of each line, each column, both diagonals should all be equal. Yep. Well, yeah, I mean, they should be equal for the result of where the tiles end up, but you're asking me to... I'm confused now. If we checked the other directions. What other directions? What, the columns? No, I haven't really checked that it satisfies the rules, but I haven't checked the columns and diagonals. Can. But for trying to understand now what... The presses on the squares are ignored, so the presses on the squares are effectively 0. Not... whatever... the current pressure. Okay, they have a pressure. Okay, fine. So they don't actually mean... when they say the sum of presses... they don't actually mean the sum of presses coming from me, but the sum of pressure in the system. So either it's coming from me, in the cases where the tiles can move, or it's already there in the system. Okay, so undo this bit. So does that... so, okay, so for the hexagons, what are they actually telling us? Like, in this picture, some of these hexagons are down, some are up. Should we be pressing them? There's still some confusion here, because why would I... so that if the presses on the marked ones are ignored, then why can't I just put 0 on those? But if I do put 0, it says the presses don't... the sums don't add up. But I thought... should we just read the hints? Maybe the hints will help us. Right numbers to balance the system like a magic square. The red squares are fixed and must be retrieved in parameters. Yeah. The values of the squares of symbols must be found. They're just using inconsistent meaning of the word press here. The symbols on the squares correspond to the position of one of the 7 hexagons. 1 bar equals 5, 1 dot equals 1. What? Each correspond to a Mayan number. A bar equals 5 and a dot equals 1. Where did that come from? Let me have a look at this again. Oh, that's where it came from. 1, 2, 3, 4, 5. It was actually right there. Okay, okay, I can accept that. Um, so that might just be it then. So it was top, top left, um, middle, top right. So it's top, so it's 15, top left, so 23. Middle, so 6, top right, 20. Um, bottom right, middle, bottom left. 10, 19, 9. Da, 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 da. Okay. We activated the self-destruct. Wait, what? I didn't want to activate the self-destruct mechanism. Why would I want to activate the self-destruct mechanism? We lost. We went there to find a cure to the pandemic, and instead we just blew up the temple. Is there a... And there's no sequel to this. Or maybe they just never wrote it. Okay. Um... That was bad. Just ambiguously worded. In both of those puzzles, they couldn't make up their mind about what the word press means. It had potential to be good if only they used the better wording. Because, okay, yeah, that Mayan number system, that made sense. It was actually written there. I didn't notice that, but... okay. That's the end of Aguateca collapse. So what, did we solve the pandemic? I don't know. Okay, well, next time I will do like the Steam House. These ones are good. Steam House I know is good because that was the one they launched this whole website with. And also Five Warriors is also good. That one they also did a competition with. The others, I think they were just badly written. It made sense, but it shouldn't be hard-coded or made to ensure that that was the only solution. Well, did my math work? I didn't actually check the columns and diagonals, so maybe it didn't actually work. You checked it? Oh. Yeah, but the hex, the presses for the hexagons were wrong. They had to be what the mural said. That was another rule essentially. Like if the rule was just that the presses had to be equal, then it could just be zeros for everything. And that would also technically give the same sum. But it was implied that everything with a symbol on it, either the marked ones or the hexagons, had to have certain values. So I don't think it was more than one solution. Um, Steam House I did solo before. How long did that take me? 2 hours, 7 minutes. Okay. We'll see if it takes me that long next time. And the other one. 2 hours and a half. Okay, it'll probably be one stream each then. I remember the Five Warriors one being pretty good. It wasn't after the translation, but all it took to make the only solution was to make sure counting the black ones didn't also mathematically work in the grid. Yeah. It seems like this whole series of the whole time travel pandemic thingy was just had a lot of bad writing in certain places. All right. Uh, is anyone ever streaming CodinGame? They don't seem to ever just stream it these days. Oh, someone is. Oh, well, it's me, of course. There was someone streaming before, though, when I started. Okay, never mind. All right, that's all. I will come back with the Steam house next time. That, I believe, is not too difficult. It's quite long, though, but not too difficult. And because it's October now, I can play some of those horror games that I've accumulated a million of and never played because I don't actually like horror games. So, later on, I'll play... What was I going to play? Well, I was thinking maybe Casper for the PlayStation, which was a fun game. Umaro seemed to want that one as well. Either that or Dead Space 2, because that's also a game I need to play. Or Fear 2, which is supposed to be not as good as Fear 1, but still something I want to play. We'll see. It'll be one of those three. Casper will probably be the easiest for me to get set up. Fear 1 is the only good Fear, 2 is okay. I mean, I quite liked the DLCs for 1. They were quite different to 1, which was, like, the mechanics were quite different, which I felt made it interesting. Like, they introduced some new weapons and I remember one of them even made some of the enemies have reflexes, which was kind of funny. In fact, I mean, I can play 2 games, so I'll probably start with Casper and then alternate between that and maybe Dead Space 2 or Fear 2. I miss Fear 1 PvP, that slapped. So I guess there was no reflexes in that because it wouldn't make sense. Yeah, that would have been good. I mean, do the servers still work? I mean, you nominated. Oh yeah, I remember kicking is actually really powerful. If you can land it right, it's basically an insta kill, at least in single player. Yeah. And the funny thing is they developed all these different kinds of melee combos you could do in a game where you wouldn't really think about using them all because it's partly because it's just a one-hit kill anyway, but also because it's mostly a shooting game. Like, you don't really want to get close to the enemies. But how much does it cost? Because you've nominated it for Wheel of Struggle, but if it's like 10 quid or something, I don't know if it really has a good chance. I mean, Wugger did nominate Quake, and that's like 15 quid, but that was an exception. Let me have a look. Here. This should be Goggable. Well, I mean, GOG is often more expensive than the Steam versions in many cases. Let's have a look at Steam. Cost is... Well, it's on sale, but normally it's like 7 quid. GOG. Is it also 7 quid on GOG? Okay. That's a decent price. I would think there's a good chance of it getting accepted. $10. Like if they were to pick one first person shooter, it would either be that or what did I nominate? I nominated the first person shooter, didn't I? Can't remember what it was. Oh no, I nominated Dishonored. That's not really a first person shooter. Anyway, that's years away before we even have to worry about that. All right, that's it. See you next time or in a few hours' time.